Hi Spring fans, welcome to another installment of Spring Tips. In this installment we're going to look at how to create a WebSocket-based API using the new Reactive Spring WebFlux API in Spring Framework 5. When we last looked at server-side events, we saw that building a server-side push mechanism using server-side events and the Spring WebFlux API was cognitively very simple, and we didn't have to do a lot of gymnastics, mental or otherwise, to make this work. And we'll find that the same is true today when we build our WebSocket API. Now, before we can build the actual API itself, we need a client, right? So we're going to build a trivial client today using Angular 4. And Angular 4 features a language called TypeScript. So we can say ng new ws client, and this will take actually about a minute for this process to abate. Now we have a new client. I'm going to open this up in our IDE. As I was saying, this project is using Angular 4, which in turn uses TypeScript. Now we've chosen to use Angular and TypeScript because it's a very familiar environment, a very familiar language if you've ever built anything using Kotlin, which we'll do for the service side, right? This is a nice excuse, since we're already using a foreign language to build this client, to also build a service implementation using the Kotlin programming language, which of course Spring Boot readily and natively supports. So we have our new application, and we're going to build the application. We're just going to build a very simple component here. We're going to go to the root component called app component, and we're going to build a simple template inline. We're not going to specify a separate one, just to keep things simple. Pro tip, I learned this one from Matt Rapel: don't let this generate JavaScript for you. So we're going to say h1 files, and the idea is we're going to have a service that lists any new files that appear in a directory, right? Not a very interesting example, but it does allow us to sort of demonstrate a few different concepts as we use the WebSocket API and the reactive sort of plumbing in the background. Now we're going to have a listing of files, but for now, let's just get the simplest machinery that we can working, so that we can sort of stub it out later and then see if it works. So let's say we're going to have a collection of div elements, one for each item in a list of file events, right? So let's say that there's a new file event that gets sent down by WebSockets to the client, which then uses those that updated information to update a collection that's keeping on the client here. Okay, so we're going to say let f of files, and we'll write out the information about the file. So we're going to write out the path and maybe the session ID. So we'll say span style font size is equal to smaller, and then we'll write out the session ID. So session ID. Very good. So now we've got that. Now we need, of course, to actually define the type. So we're going to define an interface file event like so. I'm going to give it a path string, a session ID string, and we'll write that out. And now we'll create a field to manage our array of file events, right? So file event equals an empty array list, an empty array. Now we need a constructor naturally, and then in the constructor we're going to use a WebSocket client. So we're going to say new WebSocket, and in this case we'll use the WS prefix, of course, 8080, that's where our service is running, and we need an endpoint name. So the endpoint name could be anything really. I'm going to just call it WS files, and we'll use that here in the client code. So we're going to say this dot on message equals, and we're going to give it a callback, and the callback is going to be, it's going to contain a message, a parameter here of type message event. So message event equals, and then we're going to provide a lambda here, just a callback invocation. And what's going to happen is when we get that new message event, we're going to dereference the data. We're going to store that in a variable here. We're going to store it as a const actually, since we're not going to change it ever. And we're going to parse it. All right, it's going to come in as a string, we expect, and we can then take that parsed thing and cast it to a file event. So actually, data is a file event, right? We know that because it's been designed that way, but we don't need this extra redundant declaration, right? It does type inference very nicely. So finally, we're going to write this data to the files collection, and our template will, because of the two-way binding in place thanks to Angular, it'll update with the new data. So that's about it. That's all we need for our client experience to get everything working. So let's go ahead and start that application running here in the same node, ng-serve open. It's going to start up a browser running the application in port 4200. The first time it loads, it's a little slow, but we can see it's working. It's tried to connect. You can see if you look at the console here in the network activity, it's tried to connect to localhost 8080 WS files, of course, but nothing happened. We need to provide a working service. So let's do that. We're going to go to start.spring.io. I'm going to go to the Kotlin, I'm going to choose Kotlin as my language here, and I'm going to use Spring Boot 2.0 M3. So this is the latest and greatest Spring Boot as of this revision, as of this time, which allows us to build a reactive application using Spring Framework 5 and the reactive support therein. So we're going to use reactive web, and of course we're going to use Spring integration. We'll come back to what we're doing with that in a little bit, but for now we have everything we need. So let's go to the console here, up one level, unzip WS service, cd WS service, and let's open this up. All right, now we've got a new project. So the first aim shall be to just to define a skeletal WebSocket sort of service, something that sends down basic data. It doesn't have to be particularly interesting. We just want to prove that the plumbing is working, right? So we'll do that first. WS service application, and let's create some configuration. So we're going to have a WebSocket configuration class, and the configuration class defines three things of interest. First, it defines a WebSocket handler, and a WebSocket handler is a component that responds to requests. So we're going to say return WebSocket handler. Okay, and of course we'll get a session, and the contract here is that we have to return data. Eventually we have to return an empty. We have to return the return value of calling session.send or something like that, right? Mono.empty will probably work, right? So let's try that. Return this. Does that work? No. Empty flux. Let's see. This WebSocket handler is expecting a mono void, so we can just return that. Mono.empty. Right? Flux.empty. I guess we can return null for now. Well, it doesn't matter. We'll have to come back to this anyway, so let's leave that for now. Okay, to do. And then we need a WebSocket handler adapter equals WebSocket handler adapter. Very good. That one's pretty straightforward. And then we need a handler mapping, right? So fun handler mapping equals handler mapping, and the handler mapping is a object that's designed to tell Spring, the web runtime, what components are mounted to which endpoints, right? So simple URL handler mapping, And importantly, we need this to have a certain order. Let's just say 10. It has to be something non-zero here, and we need to give it then a collection of URLs. And here we're just going to use a map. So map of, and we use one of these convenient builder APIs in Kotlin. I'm going to say that the endpoint WS files should map to WSH, which is our component there, and then we return this definition like that. Okay, so there's our handler mapping, our WebSocket handler adapter, and then finally our WebSocket handler. Now, the simplest thing that we can do here is just to return data using the session method. So the session, if we send session.send and pass in a publisher of WebSocket messages, that would satisfy the contract. So let's do that. Val publisher equals flux.generate. I'm just going to generate some data here because we want to have something to work with. So we'll generate some data using a consumer of synchronous sync of type file event. Okay, and of course we don't have that type file event, so let's create it here for our own purposes to match the structure that we have on the client. Not that we need it, but it's just convenient for our purposes for this demo to have similar objects. Okay, so we're going to use a data class in Kotlin. This makes short work of generating getters, setters, toString, all that kind of stuff. So we can now use that, and we have to return some data, right? So we have a sync that gets created for us, and our job is to return a sync and then put all that, to generate data into that sync. So we're going to generate a new record of type file event like this, and we're just going to hard code the data. So session 1, 2, 3. Or even better, we can just system.current time milli, and the path will be A, B, C. All right. So there we are. There's our custom generator, and we can return. We can say that we want that publisher to then map its output, which is the file event, into a string, right? Because we need a string. So let's use the Jackson object mapper. So we'll say Jackson object mapper, and we'll say I want to map it to a string. Now it is an implicit parameter in a lambda. If you have a single unambiguous parameter in a lambda callback method in a functional interface, then Kotlin gives it the implicit name it, or you can of course give it a parameter name like this, in which case it no longer works. But it is what I have here, so that's fine. And then we need to map that into a text message as we did before, taking it as well. And we can put that publisher here and return it, right? So there we are. Now, we have I forgot to specify the return value. Very good. So now we have a return value there, and everything else should work as we expect it to, right? So we have now this basic WebSocket handler. Nothing particularly interesting. It just, it demonstrates how to generate some data. The only problem with this, of course, is that if we let this run as is, it'll scream. It'll go just as fast as it can, not stopping, and our browser will very quickly run out of memory. So let's gate it to, let's say, 1 second, right? So we're going to insert an artificial delay, which is something that we can do because we have a scheduler in the background here, right? The Reactor project, which underpins the reactive support in Spring 5, gives us a scheduler. So let's go ahead and spin this application up, and lest I forget next time, I'm going to make sure that this application is a single instance only, so that way it'll kill the instance there. And we'll refresh the browser here. And there we go. Every second we get a new result. Now, we could stop here, but I want to connect our WebSocket API to things that are happening in the world, right? So again, just borrowing from that same example that we saw last time with the Spring integration, I'm going to adopt this API to produce a new message down to the client whenever there is a new file. Now, we're going to use this as an opportunity to use Spring integration, right? Which is not a reactive API, but it provides event-driven sort of adapters that we can then plug into the reactive world here. So what we're going to do is we're going to define a channel on which we expect new messages to arrive, right? So fun incoming files channel equals publish subscribe channel, and we'll then we'll rewrite this code a little bit to take advantage of that new channel. Now we'll talk about how data goes into that channel in a second. We're going to set up an inbound adapter, a file inbound adapter, using the Spring integration inbound adapter and equivalent support in the Spring integration file module, right? We can do that, but for now, let's focus on writing this code so that we create a handler that gets added to that channel when we create a new flux for a given session, when we create a new publisher for a given session. So let's rewrite this code a bit here. We're going to get rid of all this and get rid of that, and we're not going to be calling generate anymore. We're not synthesizing data based on the consumer. We're going to create a single publisher, and we'll give this a opportunity to specify what happens here. We're going to give our callback here an opportunity to specify what to do, and we'll send that we're going to send the data into the publisher just as before, right? So in this case, we're going to do a little bit more work, but it's going to be done elsewhere, right? So we're going to say that we want to actually send a WebSocket message, okay? And in order to do this work, we're going to say first register the connection to the client, and then second we want to connect to the client, right? So we have two things we need to do in this bit of code, and I think the best way to do that would be to keep a map of session IDs to handlers that we want to then attach to our channel that get written to whenever a message arrives for this particular WebSocket, right? So we're going to say connections is going to be equal to concurrent hash map of type string whose payloads are of type message handler. That's the Spring messaging message handler component, right? So we're going to create a custom message handler type that will then keep in that list there. So we're going to say class forwarding message handler, which is going to override the it's going to use rather the WebSocket session, and it'll use the sync WebSocket flux sync of type WebSocket message, and it's going to extend the message handler interface, of course, so we'll have to satisfy the contract, which we can do fairly straightforwardly. So there we go. So we have our custom class there, and we know we're going to store the session ID, so session ID equals session.id, and we know that we're going to need a object mapper, so val om equals object mapper. Actually, we can just use the one in scope. That'll be fine. And so let's now write this code. We're going to say when a message comes in, when we're creating a new publisher, we're not generating new values over and over. Whatever we do in here is basically a constructor. It's a factory method for a publisher. And in this case, we're going to generate a new value in the publisher by producing a new value onto the sync by calling sync.next whenever a file arrives on the inbound channel. So we need to use our pointer to the session and to the sync in this message handler to publish a message. So we're going to do that in a second. Here we're going to say message, and we'll dereference the payload. Payload equals message.payload as file, right? Because we know it's going to be a Java IO file. So we'll use that, and then we're going to get we're going to create a file event. So fe equals file event, and the session ID will of course be the session ID that we've recorded earlier, and the path will be the payload absolute path. Okay, so there's this. There we are. And then I'm going to turn that into a string, of course, just as we did before. So we'll say val string equals om dot write value as string fe, and then we'll turn that into a text message, tm session dot text message, passing in the string, and then finally we'll send that using the sync as we did before. So tm passing that in, right? So same kind of processing code, except now it's being done at the end of a Spring integration flow, right? So let's now wire that connection up. We're going to say that whenever a new message, whenever we create this new flux for a new session, for a new connection from the client, we're going to map it by its key, by its ID in here, and we're going to use a forwarding message handler passing in the session and the sync. And then once we've done that, we're going to use the channel, right? We're going to dereference the channel that we've configured up there. So we'll say incoming files channel.subscribe, passing in, of course, the connections session.id keyed message handler. Now, on the other side, once this publisher is gone, we need to clean up that connection, right? We don't want too many connections and subscribers on that channel for no reason. It'll be a memory leak otherwise. So in this case, we want to clean up that extra resource, and the ideal time to do that, of course, is when the client disconnects, which we can get to by overriding the do finally method here. So here we're going to say incoming file channels dot unsubscribe, and we're going to look up the message handler in the map as well. And then, of course, having done that, we can say connections dot remove session.id. So we can remove it from the map after we've unsubscribed it, right? We want to make sure there's no in-flight transactions first. So there we go. We've got now this. We've written a little bit of code, and of course I'm just running a publisher here to send data back. It should be noticed that mentioned that you can read data. It's just a publish. It's a flux. So it's a publisher of incoming WebSocket messages, but that's a client-initiated transaction. We're not so much interested in that as we are server or service-initiated transaction, right? So here we go. Here's our basic arrangement. We have a message handler that's going to be created each time there's a new WebSocket request or WebSocket session initiated. When the WebSocket session is initiated, we create a publisher, which will be defined as the thing that produces a new value whenever there's an event, and then of course the event has to come from somewhere. It'll go through the incoming channel, but we still need the integration flow to make it happen. So let's wire that up now as well. So we're going to say incoming file flow integration flow equals integration flows dot from, and we're going to use the files inbound adapter. And here we need to provide a file pointer. I don't actually need this in this case, do I? So I can use the value annotation to use spell or property placeholder resolution or something like this. So I'm going to use home desktop in, but of course this is Kotlin, and Kotlin has its own property placeholder resolution syntax that looks exactly the same as Spring. So we have to make sure that the language doesn't attempt to resolve these variables or these expressions, because this is not, it's not going to be in the Java in the Kotlin language. It's going to be in the Spring application context that these values reside. So we escape it using that backslash there. So what we're saying is create a inbound adapter looking at the directory there, create the directory if it doesn't exist, and then we want to create a polar. So we're going to say create a polar of type with the following metadata, right? So pm dot fixed rate, and then use that rate. And whenever a message arrives, we're going to send it on the incoming files channel. and then we'll get the whole built flow and then store it there, right? So there we go. There's our integration flow and our inbound adapter and the poller that will respond to the messages coming in off the adapter and so on. Okay, so that says look at the current directory, look at the directory specified here, which we'll call file home desktop in. Create the directory if it doesn't exist, and you should scan the directory every 1 second or every 1,000 milliseconds for any new data. If there is any new files that are there that weren't there before, send a Spring Framework message on the incoming files channel, and then something on the other end will listen to it. Well, of course, we have here a setup that creates a new subscriber to listen on that channel anytime there's a new WebSocket session. So basically, we're dynamically adding and removing subscribers based on the initiation or termination of a WebSocket session. So let's restart. Now we go to the browser, refresh, and we have to go to the command line here, cd desktop in, touch 1, 2, 3, etc. So that's one client. Go to another, touch 4, and if you can see here, both the old browser and the new browser see the new file, but they have different sessions, right? So we've now got 2 subscribers listening for the records, and you can see that reflected here as well, right? It says incoming file channel has 2 subscribers. Now let's kill this this incognito session, and you'll see that incoming file channels has now 1 subscriber. That's the one that was the one that's still active. So it cleans itself, it takes care of itself. So here we've looked at how to use the Reactive API to build a WebSocket application. You'll see that cognitively I still find this much more approachable, to be honest with you, than the Spring Framework approach, the Spring Framework 4 approach to working with WebSockets. The Spring Framework 4 approach worked just fine, and it was based on the concepts of messaging in the Spring Framework, right? So the SIMP messaging template and all this. And indeed, that work is what allowed us to extract the Spring integration message and Spring integration channel type from Spring integration and put it in Spring Framework. It's the basis of that movement. And so I'm very glad for all that work, but I just find it so natural to think about eventual things, things of streams of data that may or may not occur as publishers, reactive streams publishers. So, lots of good stuff there. Well, all right. With that, thanks very much for watching, and see you next time.